All right, so we are going to cover now absolute value equations and inequalities. So this section is going to be absolute value equations. Kind of buckle in. There's a long process to these, especially when we get into inequalities. But here are the steps that you would have to do, really 3 steps. Get the absolute value portion of the problem by itself. If the absolute value portion is a negative number when you're done, there's no solution. All right? But once you get the absolute value portion by itself, then you're going to write 2 separate equations without the absolute value symbol. One with the original answer and one with the answer as a negative. And then if there's multiple things within that absolute value problem, then you would solve for each of those. Okay, this is an example of going through all the steps. Steps 1, 2, and 3. Now, when I say get the absolute value portion by itself, that would be this whole x minus 3 portion. I'm going to write a problem off to the side here. 2x plus 3 equals 7. Now, if you think about this, when we normally solve for x here, it's a 2-step problem, right? We would subtract 3 from both sides. That would be 2x equals 4, and then we would divide 2 from both sides, and we would get x equals 2. Essentially, this is what we're doing here. Okay, but in this case, our x is the same as this whole thing is x plus 3. So I want you to think of it as its own individual x. We would subtract 3 from both sides, just like we did here. Then we divide this whole side by 2, so just the 2's cancel out, divide that by 2, and then you get x equals 2, but in this case, x minus 3 equals 2. All right, so visually, you're going to have to see that, or you're going to have to practice that the absolute value portion we're treating as a grouped item that we have to keep together, okay? So basically, once we get the absolute value portion by itself, and we do that by undoing the problem just like we would do any other problem if it was just solving for a variable, then we get on to step 2. All right, so as you can see here, the absolute value portion is by itself after we went through all this. And now I'm going to rewrite 2 separate equations. One with x minus 3 equals 2, just as we see it, and one with x minus 3 equals negative 2. Because we know that the absolute value of any number is always going to be that positive version, right? So an absolute value of negative 2 still equals 2. So if I am looking for stuff that makes this equal 2, if whatever is in here comes out to equal negative 2, it still makes that equation true, okay? So after you take the absolute value portion and you set it equal to the positive answer and the negative answer, then you solve for those. So how we got 5 and 1, you add 3 to both sides. 2 plus 3 is 5. That's 0. X equals 5. Again, add 3. Negative 2 plus 3, that's how I get my x equals 1. All right, so follow those steps. Get the absolute value portion by itself. Then set up 2 separate equalities, one with the positive answer, one with the answer as a negative number, and then solve those individual equations. All right, so let's go through a couple examples. So here we can see the absolute value portion is not by itself. There's a negative 2 here. So step 1 would be to add 2 to both sides. So now you get the absolute value of t equals negative 1 plus 2 is positive 1. All right, so now at this point, we go to our next step where we set up 2 separate equations. The absolute value portion, t equals 1, and then also t equals the negative version of that, negative 1. Now in this case, there's not any more math to do because the variable is isolated by itself, so we don't have to worry about it. That would be our final answer. In this example, we have a number being multiplied by a single absolute value portion. So just like we would undo any normal equation, like 3x equals 15, you divide by 3, we would divide this by 3 as well. These divide out, leaving me with the absolute value of n equals 15 divided by 3, 5. So again, as we get to this point, now we set it up, n equals 5, n equals negative 5. One with the positive value, one with the original value like you see, and one with the negative value. And we are done for that point. There is no final step because we don't need to solve for any of this. All right, so now let's do sample 3. So sample 3 already has the absolute value portion by itself, right? There's nothing to add or multiply that is outside of it. Just like this -2 is outside the absolute value, this 3 was outside the absolute value. So at this point, if you reference your notes, we are going right to step 2, right? 2 separate equations without the absolute value symbol. All right, so over here, I'm going to write c minus 2 equals 6, and then c minus 2 equals -6. Because if this whole portion equals -6, the absolute value of that is also 6. All right, so now we just solve for this inequality. Let me rewrite this. It's getting a little glitchy on me. I apologize. So c minus 2 equals -6. Okay, so I would add 2 to both sides to undo this. C equals 8. So that's one of my equations that can make this true. 8 minus 2 is 6. Add 2 to both sides. C equals -4. That would be my other equation. -4 minus 2 would be -6. The absolute value -6 equals 6. Okay, so for this example, since the absolute value portion is all by itself, we don't have to do any of the first step like we did in A and B. But if we did, you note now that the absolute value of whatever this is set to equal a negative number. Now we know from our previous experience with absolute values that an absolute value is always going to equal a positive, unless there was a negative outside of this problem, but we are not dealing with that right now. All right, so the fact that our absolute value is by itself and it equals a negative number, this would be no solution. All right, so we would just drop it there. We wouldn't have to do any more of that problem. All right, now for this example, we have the absolute value portion already by itself. So since it is, now we set up 2 separate inequality or equations. 7d equals 14. 7d equals -14. Now here we're just going to divide by 7. D equals 2. That makes it true. Divide by 7. D equals -2. So that would be our 2 answers for that problem. All right. So the example problem goes through a lot. We can do one more example here. I'm going to set up, let's just set up a random problem. Let's do 2 times the absolute value of x plus 3 plus 5 equals, let's say 11. All right, so if we were to do this problem, now these are all the bones of like what you would do when it gets by itself. We now need to get this x plus 3 by itself. All right, so just like if it was a problem 2x plus 5 equals 11, we would subtract 5, then we would divide by 2. So we're going to do the exact same thing here. So we're going to start by subtracting 5 from both sides. We rewrite the problem. 2 times the absolute value of x plus 3 equals 11 minus 5 is 6. The absolute value portion is still being multiplied by 2, so it's not by itself yet. So I am going to divide by 2. Then that gives me x plus 3. The absolute value of that equals 6 divided by 2 is 3, because these would divide out. All right, now you're at your final step here. Final step would be to set up 2 equations, one with positive 3, one with negative 3. So I would have x plus 3 equals 3. X plus 3 equals -3. And then you solve for each of these. Subtract 3 from both sides. And you get x equals 0 as one of my answers. Subtract 3 from both sides. X equals -6 for my other answer. So these are the two values for x that if I plug them in for this, makes that equation equal positive 11. All right, so these can be a little bit tedious, but a little bit of work. But if you follow your inverse operation rules, really the one adjustment is to set two separate equations and then go forward from there.